There we go. Hey, everybody.
Uh,
Glad you're all here. All right. Anybody have anything going on you want to share?
This week on Wednesday, we are planning to use our Airstream, which is in our lot right now, or
That's
our
pretty cool.
driveway.
Airstream, for those who don't know, is a camper.
Yes, it's a small tin camper. It's a giant tin. Her name is Susie, and we're her banshees.
That's pretty
And we're
fun.
we're planning to go north to Michigan, and then maybe stop to Six Flags on the way.
Oh, that sounds fun. I like Six Flags. They're pretty fun. I love rides. Whenever I go somewhere new, I find the amusement park nearby and go on the fastest roller coaster I can find. Anybody else like roller coasters? Who likes roller coasters? Put your hand up if you like roller coasters. Now put your hand up if you don't. A couple of you guys don't. Yeah, they're a little bit scary, aren't they? It's funny, we have strong feelings about them. All right. Anybody have any questions? All right, let us begin. Hold on one second here. Okay, hopefully you can see that where it says invertebrates, sponges, cnidarians, and worms, right? So let's take a look here. Oh, there's my first joke. I just showed you the answer. All right, what's worse than finding a worm in your apple?
half a worm.
Half a worm. Yeah, finding half a worm. Because you know what that means. I like this cartoon here. Free hugs. Don't let a jellyfish hug you. That's for sure. And what's in the middle of a jellyfish?
It's
A jelly button. Jelly button. How about this one? Why are sea sponges good at math? Because they understand correlations. Math correlation is a kind of a math term. All right, how about this one? What did the mother worm say to her son when he came in late? Where in Earth have you been? Instead of on Earth, in Earth. And were there worms in the apples on Noah's arks? No, everyone had to go in pairs. Take a minute for you to get that one. Pears, no apples, pears. All right, that's it for the jokes today. I want to talk for just a second about discussion boards and what makes a good discussion board. So discussion boards really are a good way for us to get to know one another. We can kind of recreate that classroom experience a little bit and explore one another's ideas and thoughts and comments. Now, when you're making your original post on a discussion board, make sure that you follow the directions very carefully. So if the directions tell you to upload a picture, be sure to upload a picture. Don't just upload the link.
Started.
And and follow the instructions that I give you in the lessons.
Yes.
In the course information section at the top of the assignments page when you are completing uploading a picture. Okay, that's when you're doing your own. Now, when you're making a comment on another student's work, and that's often a required part of the assignment, think about it not as a way to just meet the assignment's requirements. Think of it as a way to encourage your classmates. Don't feel that you only have to just make one comment for one student. Take a minute and go through the discussion and comment on the ones that mean something to you, that you find meaningful. So when you just say something like good job or nice, you're not really giving your classmate any kind of feedback that would be useful to them. So I'm not going to give you credit for those. And I'm not going to give you a chance to redo comments. You have to add your comment immediately after you post your own assignment. Otherwise, once you post your content, that comes to me for grading. And I assume that it's done. So I will grade it then. You can't come back days or hours later and add your first comment because you're not going to get credit for it then. All right. So if you comment on multiple posts, that's, I think, better. I think that's really a good way to encourage your classmates. And a lot of you guys have been doing a really good job on that. Now, once you post it on one person's, if you want to come back days later and post on somebody else's, that's fine. You can do that. Okay, so I've got a good example of a great discussion comment from one of my other classes. And I want you guys to see how these are very specific to the original post and how they encourage the student with what they think is good about the post. This is the kind of feedback that I'm looking for. All right, so this is the original one. Well, these are two different, the original one I didn't put there. These are the comments that would be after it. This is absolutely stunning. I love your use of watercolor with fine lines. It makes it look like a children's book illustration. The contrast between the more defined darker green of the trees and the softer lighter green makes it look like rays of sunshine. Or something a little simpler. This is gorgeous. The way you made the shading so defined gives it a beautiful stylistic look. So these are examples of things that would be a good discussion board response. Now, I've been pretty easy about grading these until now, but I'm going to start requiring more of you from now on. In addition, starting now, starting today, you will not receive credit for a photo if you just put in a link. And I'm not going to give you any more chances to go back and do them. So I've been giving second, third chances to people who just give me a link. What you need to do is go back in and double check to make sure it looks the way you want it to. If it's huge, shrink it down and make it smaller. If it's a little bitty, expand it and make it a little bit bigger. You can do that when you edit your pictures. If you can't see a picture, that means your classmates won't be able to see it either. All right. And one final thought about those discussion boards. Please don't use discussion boards to send a question or a comment just to me. Remember, anything you post on a discussion board is seen by everyone. All your classmates can see that. If you have a question for me, send it through Canvas inbox. Okay? Any questions? All right, let's jump right into ecdysis. Anybody know what that word means? You can probably tell by the picture. Alistair.
I'm guessing it likes, I wouldn't say sheds, but it comes out of its skin, or I guess you could say hatches.
Hatches would be coming out of an egg, but I get your drift.
Yeah.
Yeah.
Yeah, like a
Like you can think
cicada.
of it as molting.
Yeah.
So
that's
molting
what it
is another word for ecdysis. So in your lessons this week, we're going to learn about arthropods. And arthropods are the most common of all the animals on Earth. In fact, arthropods account for about 75%. That's 3 out of every 4 animals on the Earth is an arthropod. So an arthropod it includes the animals like insects and centipedes and millipedes and arachnids. Those are arthropods. So that word arthropod comes from 2 Greek words. Arthro means joint and pod means foot. So you're going to start tomorrow's lesson with an activity if you're staying with the due dates. You'll start with an activity that shows you why joints are an important part, why those joints are important in an arthropod. So that's a pretty fun activity to do. All right, so what kind of skeleton do all arthropods have? Remember, there are those 3 kinds of skeletons. What kind do arthropods have? Bethany.
An exoskeleton.
An exoskeleton, that's right. They have an exoskeleton. Now that exoskeleton doesn't grow, right? It's a hard case on the outside. So when it's time for the arthropod to get a little bit bigger than that exoskeleton, it has to shed the exoskeleton and then develop a new one. So today we're going to talk in some detail about how they do that. The official term for molting in invertebrates is ecdysis, but you can use the term molting too. So I'll go back and forth in this today, talking about ecdysis or molting, but that's what I mean. Now this is more detail than we're going to go into in the lessons. And the information here that I do here won't be on your quizzes or learning checks. Okay, so take a look at what's happening right there in that picture. This insect is called a cicada, and it's climbing out of its skin. Have any of you guys ever seen a cicada shell? Yeah, so sometimes they leave them behind on trees or on fence posts. They grab a hold of something. Once they've shed that shell, they don't need that anymore. So cicadas make that reap, reap sound at night. I think it's beautiful, the sound that a cicada makes. Now, this is a cute little cartoon here. What manner of armor is this? Exoskeleton. Yeah, you can think of an exoskeleton as like a suit of armor on the outside of the arthropod. So all of them have an exoskeleton that completely covers the outside of their body, and the muscles inside the body are stuck to that exoskeleton. It is hard and rigid, so that arthropod cannot grow unless it sheds the old one. And then once it sheds the old one, it can grow a new one. Now, there's a couple different kinds of exoskeletons. One kind is called chitin. You can see that right here. This is a chitin exoskeleton. It's just one kind of material that forms an exoskeleton. Another kind is calcium carbonate. So this is the structure that a coral reef is made of. Coral have an exoskeleton made out of calcium carbonate. And when the soft coral inside dies, that calcium carbonate shell stays behind. And that's how a coral reef grows. It's actually growing on the remains of formerly living coral. Now, this picture here, this is what the beetle looked like before, right here. Look at its new body right here. So growth happens in arthropods in stages. It doesn't happen continuously. Like, you know, sometimes you'll go through growth spurts, but for the most part, when you grow, it's rather gradual. It's not like that with arthropods. Their growth happens in stages, and it really depends on the temperature and how much food is available. So what do you guys think? Do you think warmer or cooler temperatures would result in more molts, or rather shorter time in between molts? What do you think? Raise your hand if you think warmer temperatures give more molts or shorter time between molts. How about if you think colder temperatures? Just a couple of each. Yeah, it's actually warmer temperatures, because when it's warmer, they can grow faster. So as they grow faster, they need to molt again or go through ecdysis again more quickly. And of course, more food is going to help them to grow faster too. So the more availability we have of food, the larger the arthropod is going to be. So the more quickly it has to shed that outer exoskeleton. Now this picture right here, just look at the picture for a minute. This shows a piece of the exoskeleton as if it's taken from the side. So we took a piece of the exoskeleton and we're looking at it from its side, with this being the outside and this being like the muscle layer that would be inside here. This bristle right here, that's a hair, like you would see on a hairy spider. So take a look at these layers. There's 3 layers. There's an exocuticle, an epicuticle, an exocuticle, and an endocuticle. Those are 3 layers of the cuticle. And then underneath is the epidermis. That's a layer of cells. There aren't any cells in the cuticle. So the outer hard part, that is the actual exoskeleton that would be hard, that you wouldn't be able to see. It is secreted by these epidermal cells, by the cells that are in the epidermis. And then they harden once they get in contact with the air. Now, right down here, epidermis, that's skin, like our skin. Our skin is epidermis. We don't have a cuticle on the outside of our skin. We don't have an exoskeleton. So beneath that exoskeleton, there is an underlying cell layer, and that secretes, this part here secretes this cuticle, which then dries out. Now together, that exoskeleton and the epidermis, which is this part right here, epidermis, form what's called the integument. Integument in us is our skin. The whole thing is our integument. Now, molting really is a really complex process, and it starts in a gland right behind the base of the brain. Now, this picture here shows the nervous system of a typical arthropod. Of course, they're all going to have a little different nervous system because they're differently shaped. But here's the brain right here. Right behind the base of the brain, there's a gland that will start the process of molting. So early in this process of molting, these epithelial cells, right in this area right here, they start secreting what's called molting fluid. Well, that molting fluid contains enzymes, and they secrete it right here between the old cuticle and the epidermis. Now, those enzymes right in that area right there, that's where they're secreted. Those enzymes start to digest a little bit of this endocuticle, and the epidermis then will absorb the stuff that was digested. The endocuticle gets digested because they can use it again. So it's recycled. So that the enzymes are right here. They digest the endocuticle. The epidermis then begins to absorb that new that endocuticle in order to make more. So think about the advantages to the arthropod of absorbing that old endocuticle. For one thing, it reduces the amount of energy that is needed for molting because they're getting a little bit of energy back. Now, the outside, this part right here, this exocuticle and epicuticle, they can't be recycled. They can't be reabsorbed. They're just too hard. So they're just discarded. That's what you find when you find the shell of a cicada on the outside of a tree. That is the outer part that can't be reabsorbed. All right, so let's watch this video and you can see how that happens. The video doesn't have any sound, so I'll talk through it. So this is the hormone right here that's produced by that gland, and it's secreted right in here, and it begins digesting those that cuticle. So the cells themselves are beginning to divide. Now that once that layer is reabsorbed, now there's a space in between the epidermal cells and the outer cuticle. It's called the ecdysial space. That's the molting gel right there. A new protective layer is secreted to protect the epidermal cells, to keep them from being damaged when the molting gel is activated. As soon as the protective layer is complete, the gel is activated and it becomes a fluid. You can see it dissolving away, that endocuticle. That continues until it reaches the old protective layer or the exocuticle. The remaining molting fluid is then reabsorbed. There's the new cuticle forming. And this is the outer part that's shed. It's called the exuvium. And that's what you find on the side of a tree. All right, so the process of shedding, of getting rid of that outer exoskeleton, is called ecdysis. And what happens is the animal contracts its muscles and takes in air or water to cause the body to swell up. That swelling then splits that exoskeleton, usually right along the back, as you can see here in this picture, and the arthropod climbs right out. So if you see a cicada shell in the woods sometime, take a look at it. You'll see that there's a split right down the back of it. Now think about what it would be like if you had to take your clothes off that way. The first thing you'd have to do is shrink your body away from your clothes. Then you'd have to have a giant drink of water to make your body swell up enough that your clothes split right down the back. Then you would step out of your clothes. That's in effect what's happening in this ecdysis. Now, when the arthropod first comes out of its old exoskeleton, it's very pale and wrinkly. It swallows more air to expand that exoskeleton, smoothing out the wrinkles, the new exoskeleton here, smoothing out the wrinkles. Then another biochemical process takes place that hardens and darkens that new exoskeleton. And that takes several hours. So take a look here at how much lighter the new exoskeleton is than the old one was. Now the pale insect, this one, it has an exoskeleton, but it hasn't been hardened and darkened by the air. And think about how vulnerable this insect is during this time. It still has an exoskeleton, but that exoskeleton is very soft. It's a tasty treat and easy to eat by anything that wants to take a bite of it. So this is a very fragile time for that arthropod when it's just come out of its old exoskeleton. Now, most arthropods are going to molt somewhere between 4 and 7 times before they become an adult. And even though it only happens occasionally, most arthropods do continue to add layers to the inside of their exoskeleton all the time. Now, some insects do this every 24 hours, and they might even form rings that are similar to the trees. So scientists can take a look at how many of those new exoskeletons there are to know how old the insect is. I thought you guys might like to see a couple cool videos that show invertebrates molting. This is one of my favorites. This is a red king crab molting. So it's pretty cool video. It's 2 minutes long, which is longer than I usually do, but I think it's so cool I didn't want to fast forward through any of it. So let's watch this. Molting is the process of shedding the old exoskeleton so a crab can grow. Prior to molting, the crab absorbs seawater and starts to separate their new shell from their old shell. This is the shrinking away of the body as it separates. Absorbing seawater makes the crab swell, causing its old shell to crack along a special seam. Hard work to climb out of that old shell. But here it comes. The new shell is very soft, allowing it to bend and squeeze as the crab pulls out of the old shell. After molting, the crab begins pumping seawater into its body to expand its new shell. Isn't that cool? And it goes off and leaves that old exoskeleton behind. Takes a few days for the new shell to harden. And during that time, that crab is pretty vulnerable to predators, much more so than after that shell hardens. All right, now, cicadas are those insects that you hear making that reep, reep sound. A lot of people will call them locusts. They're not. Locusts are not the same as cicadas. Locusts have giant hind legs that are really good for jumping, and locusts will strip an entire town bare of plants in no time. Cicadas don't do that. So let's watch a cicada molting. There's that split right along the back. You can see it right here. Notice how even the legs were inside the legs that are here left on the tree. Pulls all those right out. Watch the wings expand. So it pushes air and water down into the wings to expand them. And once again, this cicada is very soft until that new exoskeleton gets harder. That can take anywhere from hours to days, depending on the kind of arthropod it is. All right, I like this one too. Take a look at this long antenna right here. I want you to see when it comes out of the molt, how it works really hard to clean that antenna. All right, let's watch this. You can see the split right there. These are the long antenna right here. Him cleaning the antenna. So that's one of his first jobs outside of the molt. So that shows you just how important those antennae are to the katydid, any arthropod, any insect. Almost done. Now he's out. So that exoskeleton of insects is made out of chitin. Now, chitin is pretty fibrous, so it's tough. It does a good job of protecting them, but it's not very nutritious. So most of them just leave it behind. And decomposers like bacteria and fungi will come along and break it down and make use of it. Now, it's pretty amazing how complex arthropods are. We a lot of times think of them as being just really simple. They're bugs after all, right? They're insects. But think of all the complex chemical reactions that have to happen just in order for them to molt. It's pretty cool. All right, I thought you might enjoy a couple of fun facts about molting. First, crabs eat their own shells. So the chitin exoskeletons tend to not be very nutritious, but the ones that are made of calcium carbonate are. So when the crab, after it molts, it is going to consume that old exoskeleton to get more calcium. Then they will use that new calcium to harden their new soft shells more quickly. So if they're able to eat their old shell, they can be safer, faster. Butterflies' times between molts are called instars. I think that's a cool name. So caterpillars, of course, are the larval stage of the butterfly. And caterpillars molt several times. The stages in between the first and second, the second and third, etc., those stages are called instars. And like a lot of other species, they can molt as many as 5 times before they finally then go into the pupa stage where they then become a butterfly. At the tarantula. The word autonomy there means the ability to grow back a body part. So tarantulas can regrow limbs, their arms that they might lose during molting. So if they lose one of those legs, the next time they molt, a new leg can regenerate right inside there. Now, over successive molts, that regenerated leg will get bigger and bigger until eventually it's close to its original size. Now, with a lot of animals, if they have trouble molting, if like a piece of them is stuck inside, they didn't do a good enough job pulling the muscle away before they started coming out, that can mean death to the arthropod, because now they're stuck and they can't get out. So even if just one part of their leg is stuck. So it's a pretty important process to be done correctly. Octopuses also shed their skin regularly. Now, they're not traditionally associated with molting because they don't have a shell on the outside, but they do shed their skin. So they slough off these patches of old skin, especially in their arms, in order to keep them flexible and to avoid infections. There's this process called super elongation, and there are certain insects like mayflies in the picture there. Mayflies undergo this super elongation while they're molting. So what happens is their internal organs stretch to allow the insect to grow larger before it fits into a new exoskeleton. So that'd be like you intentionally stretching out your stomach, intentionally stretching your heart and your lungs. They do that in a process called super elongation. And some animals will, some arthropods, like ant species is a good example. They help each other during molting. So they will assist other members of their colony by helping to remove that old exoskeleton. So that's especially important where a stuck exoskeleton might be fatal. So that is, a good thing to help one another to help out the whole colony. All right, anybody have any questions about molting? All right, so we're going to play a game now. This is a Jeopardy game. Anybody not know what Jeopardy is? All right, I will explain what Jeopardy is. So let's do, all right, so a show of hands. How many want to do, one, two, three, two. How many want to do teams of students against other students as opposed to all of you against me? So students against students, raise your hand. Students against teacher. All right, you win. Students against teacher. So let me drag this in and I'll show you how we play. So team one will be students. Team two will be teacher. There we go. All right. So what we do is you pick a category and a point value. So you would say something like Cnidarians for 200. I would click on this and ask a question. Now in real Jeopardy, the kind you see on TV, you have to give your answer in a form of a question. I don't do it that way here. So you can just, it'll be a question. You can just say the answer. You don't have to say what is or anything like that. All right. So here's how we'll play it. If any of you can answer the question, students get a point. If nobody can answer the question, I get a point, or the points. So if it's a 500, I get the points for the 500. Okay. All right. So let's see here. Let me write your names down real quick in order. So I've got Alistair, Felicity, Beth, Kian, Daniel, Muhammad, Aaliyah, Hannah, James, Hiba. All right, that just happens to be the way you appear on my screen. It's probably the way you entered the room is why it's like that. So we'll just go in order with picking the number. So I'm going to go with Alistair first because he's first on my screen. Alistair will just pick the category. So he'll say, worms for 100 or whatever he wants. And then you all can answer. So Alistair doesn't have to answer. You don't have to answer yourself when you choose. It's just a matter of if any student can answer the question, then the students get it. If no student can answer the question, then I get one. Okay? All right, Alistair. Pick a category.
I think we'll go sponges for 500.
Sponges for 500. All right, here is the question. One form of reproduction occurs when a piece is cut off a sponge and grows into a new living sponge. This is called, all right, we got budding. Any other guesses? All right, 5, 4, 3, 2, 1. This is called regeneration. Regeneration. So budding happens with plants. We'll learn about budding with plants and some animals too, where they it isn't when a piece is cut off, it's when they will grow again. I'm gonna hold on just a second. All right, I'm going to give you that one because this actually is sometimes called budding. I thought so. So regeneration or budding, but I'm going to give you guys that because James is correct. Okay. Okay, why isn't this? Edit the score and change it to a number. I don't know what that means. All right, this worked when I tested it. Let me double check this. Give me 1 second, everybody. All right, I'm going to have to keep score manually because this isn't working. So I will write it down and keep score manually. I have a feeling you guys are going to win. All right. So students is 500. All right. So next on my list is Felicity. Felicity, you choose a, choose a category and then a number.
General anatomy 500.
500. This is the basic unit of all living things. It contains a nucleus and organelles. Yeah, good job, everybody. It is the cell. Very good. All right, another 500 for the students. All right, so next is Beth.
General anatomy 400.
General anatomy 400. When tissues group together for a common purpose, they form all right. You think so? They form an organ. A couple of you guys got it. Well done. All right, I was right. You guys are you're gonna win. Am I gonna get even one right? one point. Next we have Kian.
Skeletons and temperature 500.
This is the scientific term for cold-blooded. Anybody disagree with James? Exothermic? Ectothermic? All right, it is actually ectothermic, an ectotherm. Exo means out, so you would think so, but ecto also means, you know, we have an exoskeleton, but is ectotherm is what the official term. That's okay, that's okay. You guys got it, so that's what counts. Like I said, you're working together as a team this time. And next we have Daniel.
Worms and Misc 400.
Worms and Misc for 400. This type of animal lives in or on the body of another living organism.
Parasite.
Yeah, you guys, good. It is a parasite. So there's 400. Excellent. All right, next is Muhammad.
Cnidarians 500.
Okay, remember that C is silent.
Nigerians.
There you go. For 500?
Yeah.
There you go. Cnidarians for 500. This type of cnidarian body plan looks like a bell with tentacles hanging down. All right, James says Medusa. Do we all agree? It is a Medusa. The Medusa is the one like the jellyfish that swims with its tentacles trailing behind. All right, so that's another 500. And next is Aaliyah.
Sponges, 400.
400. Sponges sometimes reproduce by a method in which a part will grow off the side of the parent animal and then separate from the parent, float off and begin to grow somewhere else. We call this, and this is very similar to the first one. Yeah, budding. Yeah, this is called budding. So it's a little bit different than the regeneration, but close enough that I gave you regeneration. So that is 400 more for the students. See if this will take. No, still isn't taking. The score for this team is not a number. Isn't that weird? How can that not be a number? They look like numbers to me. All right, next is James. Oh no, I'm sorry. Hold on a second. Hannah.
Sponges.
For how much?
200.
Sponges are members of the phylum. What phylum are sponges in? Anybody else? All right. Yes, James has got it. It is phylum Porifera. So the way I remember that is I think of the word porous. Like if something is porous, it means that, you know, water will go through it. So a sponge, kind of water goes through a sponge. So it's porous. It is Porifera is the phylum. So that was 200. And I still don't have a point. Now, James, it's your turn.
Worms for 500.
Worms for 500. Some invertebrates defend themselves by resembling species that are more dangerous than they are. This is known as what? You got it. You got it. It is not imitating. Muhammad's real close there. There you go. There you go, Beth. It is mimicry. Mimicry. Identity theft. Kian, I love that. Identity theft. Yeah. It is called mimicry in our invertebrates. All right. So that was 500 more. I think all the 500s are gone now. So all the hard ones should be over. All right. Heba, you are next.
Cnidarians for 400.
Cnidarians for 400. This type of cnidarian forms beautiful colonies that provide homes for many other species of underwater animals. Yeah, corals. Yes, that's absolutely true. Coral reefs are very beautiful. And remember what those colonies are. They're that calcium carbonate exoskeleton that has been shed by the coral after they die. It's what remains behind. All right, pretty cool. So that was 400. Okay, now we are back to Alistair. Everybody got a chance, right? Yeah. Alistair, you're next.
Skeletons in temperature for 400.
This is a flexible skeleton made by the pressure of fluid inside the body.
Hydrostatic.
Yeah, this is a hydrostatic skeleton. Very good. All right. And Felicity.
General anatomy, 300.
A group of cells that perform the same function form a what?
Tissue.
Yeah, very good, Hiba. They form a tissue. You got it. All right, so that was 300. don't know why I'm counting. So pretty clear who's going to win this one. All right, next is Felicity. Oh, wait, Felicity, did you do that one? Yeah, all right. So Beth, you're next.
Skeletons and temperature 300.
This is what we call a skeleton inside the body. Whoop. Sorry. Get that back up. There we go. Inside the body.
Endoskeleton.
Endoskeleton. You got it. An endo. Look at that one. Skeletons are cool. That is an endoskeleton. All right. Kian.
Sponges 300.
Sponges are sessile. What does that mean?
They stay in one place all their lives.
Yeah, very
Most of
good.
them.
They're generally attached to something, like a rock or the side of something hard. But yeah, they can't move from place to place because they spend their lives attached. Very good. Excellent. All right, next is Daniel.
Worms and Misc 300.
This type of worm is the simplest of all animals that have bilateral symmetry. Remember, we've got 3 types of worms, 3 different phyla. Oh, I shouldn't be giving you hints.
Flatworms.
Flatworms. Mohammed says flatworms. Anybody disagree? It is a flatworm. Very good. So remember that the ones that come before that, like the cnidarians and the sponges have no symmetry at all. Cnidarians have radial symmetry. Flatworms are the next most complex, but they're the simplest of all the ones that are bilateral. Very good. Very good. All right. Next we have Mohammed
Nidarians.
for 300.
300.
All
Yeah.
right. What kind of body shape do anemones have? Not body symmetry. Yeah, Beth's got it. They are called polyps. So remember, when a cnidarian has upright tentacles, that's a polyp. When they hang down like a bell, that is a medusa. Polyp, medusa. All right, excellent. Now we are to Aaliyah.
Worms 200.
Worms for 200. These worms are among the most abundant of all animals and have a tube shape.
Roundworms.
Yeah, they are roundworms. Very good. I didn't want to say have a round shape. That would have given it away. All right, next we have Hannah.
General autonomy for 100.
This is what we call it when you can draw a line down the center of an animal's body and it looks the same on both sides.
Bilateral
Yeah, you
symmetry.
guys got it. Bilateral symmetry. Excellent. All right, next is James.
Cnidarians 200.
Cnidarians 200. This is what cnidarians are known for. In other words, what makes a cnidarian a cnidarian? All right, 5, 4, 3. Beth, just in time. Yes, they have those stinging cells. The stinging cells are called nematocysts. This is a good picture of what they look like. They're kind of spring-loaded spears that are inside these nematocysts. All right, excellent. And Hiba.
Skeletons and temperature 200.
This is the scientific name for warm-blooded. Yeah, good. Endotherm. And endotherm is, or endothermic. Exactly. That's great. Excellent. All right. So you guys got all the points. We don't have enough for everybody to go around again. So I'm just going to go through and we'll see if you can answer them. What type of symmetry does a sea star have?
Radical symmetry.
I mean,
It is not radical, radial. Radial. I like radical better though. I want to start calling it radical. Yeah, radial symmetry, like a wheel. This is a hard outer coating on an arthropod.
exoskeleton.
Exoskeleton. Very good. How do you pronounce this word?
Cnidarian.
Very good. Very good. Cnidarian. The C is silent. Sponges have no what and no what? There's two things that sponges do not have. 5, 4.
What is symmetry?
Symmetry. They don't have any symmetry.
And
You're
no
right about
brain.
that. And no what?
Brain.
Veins?
Brain.
Oh, no brain. Well, they don't. That's true. But let's be a little less specific than that. When we're talking about sponges as a rule, we say this
No
about.
anatomy.
They do
They
have
have
anatomy. There's a word that we use for. You know what, you guys. Should I make you get? I'm going to make you get exactly the right word because I want to get at least 100 points out of this game. Oh, James, you got it. It is. They do not have symmetry or tissues. All right. So all the points to the students, 0 points to the teacher. Very good. Very good. All right. This is excellent. So yeah, let's, hold on here. Let me see here. Yep, we got them all. We got them all. All right. So if I do this again, I'm going to make some really hard questions if we're going to play teachers against students against teacher. What about, oh, there isn't one more. I didn't see that one. Thank you. There we go. An earthworm is this type of worm.
Roundworm.
Roundworms. Segmented worms.
Are you? Nobody? Yeah, there you go. Purposely. You're just patronizing me, James. Yeah, it is a segmented worm. Remember that earthworms have these little segments inside them. Yeah, you almost lost. I'm going to make it a lot harder the next time. But thank you. I didn't even notice that one up there, hiding up in the corner. Excellent, though. I'm thrilled. So you guys did really well. If you didn't know any of these, this is a really good review of what we've been doing so far in the invertebrates category. So if you didn't know any of these, it'd be a good idea to look back and read through the parts that maybe you didn't know. All right. Anybody have any questions? All right. We're a minute or two. We've got 2 minutes left. Is there anything you want to talk about? What's that official word for molting called? What have we been learning about this whole class? The scientific term for arthropod molting. Do you forget?
Eddy something.
Yeah, you're close. Real close. Ecdysis. Ecdysis. There you go. There you go. All right. You guys can go ahead now. Thank you for coming. It was a great day. Even though I lost badly, I don't mind. All right. Have a wonderful week, everybody. I'll see you
Thank
next
you.
time.
Bye.
Bye. Thank you.
Thank you.